Lesson 11, Precalculus. This is Chapter 2, Section 3, Real Zeros of Polynomials. Okay, to find real zeros of polynomials, we have to go back to an Algebra 2 concept of long division and synthetic division. So recall here when you divide, we got 4x plus 5 divided into 4x to the third minus 7x squared minus 11x plus 5. So we want to get the first term here, 4x squared, so that when we subtract, we have 0. So a quick way to figure out what you need to multiply by if it is challenging is you divide these two. So 4x to the third divided by 4x is just x squared. So we're going to multiply across by x squared. X squared times 4x is 4x to the third. X squared times 5, 5x squared. Subtract, negative 7 minus positive 5 gives you negative 12 x squared. Of course, that's gone. And then to get negative 12x squared, again, divide by 4. Negative 12 divided by 4 is negative 3x. Multiply again, so negative 3 times 4x, negative 12x squared. Negative 3 times 5, negative 15x. Subtract. Negative 11 minus negative 15 makes that plus 15. So that ends up with 4x plus 5. And so you just need a 1 up there. And so there is no remainder. When there is no remainder, that means it's a factor of it. So 4x plus 5 divides evenly into this, which changes it to 4x plus 5 times x squared minus 3x plus 1. So if you wanted to keep going, you could factor that, but it doesn't factor. So what you could do is use the quadratic equation to find the other zeros of it. So we have the 1 0 here, setting it equal to 0 and solving it. You've got negative 5 fourths. And to find the zeros from this one, you do the quadratic equation since it doesn't factor. All right, so the next one down here, practicing our long division, we've got over here x squared minus 2x plus 3 divided into x to the fourth. There's no 3 there, so we're going to put a 0 there. 0x to the third plus 3x squared, and there's no x, so I'm going to put a 0. 0x plus 1. All right, so x squared divided into x to the fourth is x squared. So multiply across by x squared, so that gives you x to the fourth, 3 x's, and then 2 x's. So minus 2x to the third plus 3x squared. Okay, so subtract, those are gone. 0 minus negative 2 is positive 2. And then that was gone, but I better leave something there to hold the spots. Again, divide x squared by 2x to the third to figure out what we need to divide into here, what we need to multiply by, and that would be 2x. So 2x multiplied across would be 2x to the third, and then minus 4x squared plus 6x. So when you subtract, you end up with this. So to get 4x squared from x squared, that'd be plus 4. Multiply by 4, so that'd be 483. And then subtract, and that gives you 2x minus 11. So that has a remainder. So since it didn't go into it evenly, there's a remainder, and it's not a 0 of it. Another way you can divide is by using synthetic division, but you can only use synthetic division when you're dividing by a monomial or by something that's linear to the first power. So this one was okay. We could have done synthetic division on the first one we did. For the second one we divided by x squared. You can't use synthetic division on that. All right, so the first one here, recall when you do synthetic division, you're dividing by the 0. So set it equal to 0 and solve it, and you get negative 3. So negative 3 end up 5x to the third plus 18x squared plus 7x minus 6. Everything was there. 3, 2, 1, it's all there. So 15, 18, 7, negative 6. All right, so that's what you do to line things up when you're doing synthetic division. you bring down the coefficients of the whole thing. So we brought down the coefficients of the polynomial, and we divide then by the 0 of that. So bring down the 5. That's the first step. Bring down the first number, multiply, then you add, multiply again, add, multiply, and this one is a 0 of it. It divides into it without a remainder, so that means x plus 3 is a factor of it, and that leaves behind, we divided a 0 out of it, so that leaves behind 5x squared plus 3x, and then minus the 2. 5, 3, 2. Again, there were 3 x's, now there's 2 x's left because we divided one out. So what you could do from there then is do the quadratic formula to figure out what the other 2 of them were. Okay, the last one here, divide by a negative, to figure out the 0, again, set it equal to 0 and solve it, and you get positive 3 over 2. I'm going to change it to a decimal, 1.5. 3 divided by 2 is 1.5. And then bring down the coefficients of the polynomial. We're missing an x on this one, so I'm going to put 0x down. So that leaves 3, negative 4, 0, 5. Okay, so again, you bring the first one down, the first number down, you multiply, and then add again. Multiply 1.5 times 0.5 gives you 0.75, add. Multiply 1.5 times 0.75 is 1.125, and add that to the 5 gives you 6.125, so it has a remainder. So again, by what we're learning in this section, it's not a 0 of it or a factor. In the world, and so on the next page here, this is kind of going old school. We have calculators now that really help us out find zeros of things. But going old school, what you do is you take all the factors of the last term of the polynomial divided by the factors of the first coefficient of the polynomial of the leading term. And that gives you all possible zeros of it. So that's what this rule says. So what we're doing here, so it's plus 16. To find the possible, they want us to find the possible zeros of f on this. So you take all the factors of the last number, which is 16, over all the factors of the leading coefficient, which here was 1. So the factors of 16 are 1, 2, 4, 8, and 16, and then the factors of 1 are just 1. So that gives you all the possible factors of it. Again, plus or minus all of them. And then it says to find the actual rational zeros. So what you're supposed to do is you're supposed to try each and every single one of these and see which one of them works for it. This has up to 3 answers because it's to the third. So you could start maybe with the number 1 and try it using synthetic division. It's the quickest way. So when you do that, let's see, multiply, and then we're going to add them up. And multiply again, add it up. That's not 0, so it's not a factor of it. Let's try the next number there, 2. So if we try 2, divide it into it using the synthetic division. And you'll see then you get 0, so 2 was a factor of it. And then you could keep on doing that till you find all 3 of them out of the possible rational zeros. All 3 answers are there. But honestly, the quicker thing to do is put in your calculator, cheat a little bit here to find out which ones they are. Because honestly, overall, you're always going to be allowed to use your calculator. It's very unusual for any of your math classes that you ever take, they're going to say you can't use it. It's just not going to happen. So put it in the calculator, hit graph, and then the quickest way to do it is use the table from there. We've got 3 zeros are showing right here on the picture. So the zeros are negative 2, 0, 2, 0, and 4, 0. Negative 2, 2, and 4. So what you could do is use your calculator to help you, do them all. And then you could actually do then is use those to divide into it. Divide all those 3 into it, and then that would show you the possible rational zeros if you need to show your work on it. All right, on the next page, it's the same idea. We need to list the rational zeros that are possible on it. So again, the last number here, which is -2, divided by the factors of the first number, 4. The factors of 2 are -1 and 2, or 1 and 2. The factors of 4 are 1, 2, and 4. So it gives us 1 over 1, 1 over 2, and 1 over 4. And then using the 2, we got 2 over 1, 2 over 2, and 2 over 4. So that gives us possible zeros 1, 1/2, 1/4, 2, and then 2 over 2 is 1. We have that already. 2 divided by 4 is 1/2, and we have that. So there are 8 possible zeros of it. So again, what you could do is try them, or if you want to show work on it, do synthetic division and show that they make 0 when you do it. All right, so the very last one here, find all the real zeros of the polynomial. This one's a little bit more fun because they don't all come out on your calculator, so you get to see how you can use synthetic division to find the extra ones. All right, so if you're going to start again showing all the work on it, you could show the possible factors of 30, or the first term here is 6. So dividing by 30, you got 1, 2, 3, 5, 6, 10, 30. I think that's all of them. And then the factors of 6. All right, so you've got a ton of them here. There's going to be a lot of choices. But again, you could use your calculator, put it in the calculator. You've got 6x to the 4th plus 33x to the 3rd, and then minus 69x plus 30. And this is going to show us a couple zeros. So again, it can have up to 4 answers on it. So let's see if any of them just show up in the table. Ah, look, they do. -2, 0, and 1, 0. And spoiler alert, the other 2 aren't pretty zeros, so we'll use those. So far we have x equals -2 and x equals 1 for the zeros, which if you were going to factor it, that factors in the x plus 2 and x minus 1. All right, so keeping going here. So we got 2 more to find. Again, they're not easy to find because it doesn't factor. So what we have to do is divide these into this. So divided by the -2, we got 6, 33, -69, and 30. It's going to do synthetic division. All right, so bring down the first number, multiply, add them up, multiply again. Oh, I think I did something wrong. 6, 33, -69, 30. Bring the first number, multiply, add them. No, I didn't do anything wrong. So let's see. -42 and -69 gives me 111. Well, we want 0, so I obviously did something wrong. You're probably all screaming what I did. All right, so -2, 6, 33, -69, 30. Bring down the first number, multiplied. We added them. Multiplied. No, don't see it. This is a sad story. Let me see. Oh, shoot. I know what I did. All right, so the 0 was -2. So since the 0 was -2, no, that's what you do. You divide by -2. 6, 33, -69, 30. Oh, I know. We're missing a 0, 0x squared. I hope you're all laughing at home. All right, so -2. We got 6, 33, 0, -69, 30. I lost my zeros. See, I told you you got to be careful and don't forget your zeros. All right, so bring down the first number, multiply, add, multiply again, add them up, multiply again, so it's positive 84. So then 84 minus 69 gives me 15. When I multiply, then I have 0. So again, I knew I did something wrong because I wasn't getting 0, and it had to be 0. So I persevered there until I figured out my silly mistake. That was disappointing, but a learning lesson for us. All right, and then we're going to divide out the 1. So I'm going to put a 1 over there, divide it into 6, the 21, the negative 42, and the 15. So bring down the first number, multiply, add them up, multiply, add them up again. So I'm going to do 42 minus 27. So that gives me negative 15. Multiply and add them up. So left with that. So as I said, it factored in the x plus 2, x minus 1, and now times this, 6x squared plus 27x minus 15. That's what's left because we divided 2 of the x's out. There were 4 of them, but now there's 2 of them left. And so this doesn't really factor anymore. I mean, you can take a 3 out if you want. It doesn't really matter though. But what the key is here, to do the rest of it, you're going to have to do the quadratic formula. So negative b, negative 27, plus or minus b squared. So 27 squared minus 4 times a times c over 2 times a. So that gives us negative 27. And then under the radical, we've got, let's see, 27 squared minus 4 times negative, well, times 6, times negative 15 gives you 1089. Oh my gosh, it's a perfect square. How is that possible? So second square root of 1089 and 33. So shoot, it did factor. Interesting. So you got negative 27 plus 33 divided by 12 and negative 27 minus 33 divided by 12. So that's a bummer. It did factor. So negative 27 plus 33 is 6 divided by 12, or a half. And then negative 27 minus 33 divided by 12 gives you negative 5. Okay, so those would be what the other two zeros are on it, 1/2 and negative 5. I'm going to go back up here and write them down. 1/2 and negative 5. So that gives you x plus 5. And then the 1/2, what you can do is you churn it, and that makes it 2x minus 1. You churn it and you change the sign to make it into a factor. See, because if you set that equal to 0, 2x minus 1, move the 1 over, you get a positive 1, divide by 2, you got a half. The bottom of it becomes the front of it, and the top of it's the back of it. It was a positive, so it's a negative. So just turn it, 2x minus 1. And then that way there are factors of it, and all the coefficients of it, and all the numbers are integers, which is something that sometimes people want you to do on these problems. Okay, well that was fun. So I'll see you for the next lesson.